Hello test takers, and welcome back to Exam Prep Solutions. And today we're going to be doing a statics problem here. It's kind of a tricky one. You're going to have to be careful about how you conduct your math here in this one. So we're going to go over that here. Remember, we have a guide called the 5 Steps to Solving Any FE Exam Problem. You can find that guide in the description box down below. It is 100% free. Anyways, give this problem a shot before I go over the solution, and then we'll see what you come up with, and let me know what answer you got in the comments down below. Anyways, I will dive into my solution here. So the problem states, find the reactions of the following static beam system. We're looking for the y direction reactions. And so I want to find what AY and BY are. Obviously AX is just going to be negative 10 or 10 kips in this case. We're interested in the AY and BY reactions. So the first thing I'm going to do is sum the moments about A sub y. So sum the moments about A sub y equals what? Well, we have to choose our direction. So I'm going to choose that counterclockwise, or excuse me, clockwise is going to be the positive direction. So clockwise is positive. Hopefully you understand my notation. When you write this down, it's a little easier to do. So now we have 8 kips times 10. That's going to be positive actually, because that's going to take us in the clockwise direction. I should put CW instead of CC. There you go. Clockwise. So 8 times 10. Now let's think about this next one. We're going to have minus 10 kips, but what do we have it multiplied by? 20 feet or 10 feet? Here's the important piece here, right? This force is going in this direction. And so when we're thinking about moments and how it's rotating this entire body, this direction is, or this distance is what matters. This is the fulcrum, or the moment arm is actually 10 feet. Not 20 feet on this x-axis here. So we want to have 10 times 10, and that's going to be a subtraction. Also, this B sub y reaction is going to theoretically rotate this the static body this way. So that's also going in the negative direction. So that's going to be 30 feet times B sub y. So that's the setup for our equation here. So you have 80 minus 100 minus 30 B sub y. So this is our equation, equals 0, right? Because it's static. So now we want to solve for B sub y. So now we have negative 20 minus 30 B sub y equals 0. And we do some basic algebra here. We're going to end up getting a result. So we're going to have 20 divided by 30. That equals 0.667. I'm just going to go with 0.67. So by, and so that's going to move to the other side. That's going to be positive. Positive divided by a negative. So it's going to be a negative answer. So negative 0.67 kips. And since it was negative based on how we have constructed our coordinate plane here, that's going to be 0.67 kips down is what B sub y is going to equal. So here's the tricky part, right? We want to make sure that we apply this moment arm correctly, or you're not gonna get the right answer. So now if we sum the moments, or excuse me, sum the forces in the y direction, we have negative 0.67 since it's 0.67 down, minus 8. This is an x force, so that's not going to come into play here. So we have negative 0.67 minus 8 plus a sub y equals 0. So we're going to end up with a sub y equals 8.67 kips up. So if we look at our answers here, it's going to be answer D in this case. So what we did is we make sure we calculate the moment correctly about a sub y, finding the correct moment arm. That helps us get the right result for B sub y. And as a result, summing the moments in the y direction, getting the right answer for a sub y. So that's how to solve this problem. Let me know if you have any questions in the description down below, or any problems you'd like me to solve. Leave a recommendation in the description. Otherwise, thank you so much for watching, and we will see you guys next time.